All right, question number 6 in paper 2 is a logarithm question. Now in actual SPM question, you may not see this in paper 2, yeah? But this is from 4. You don't have much question to ask, so they will ask this in paper 2. So given that log base 10 of x equals to a and log base 10 of y equals to b, we have to express log base 10 of square root of 100x over y squared in terms of a and b. So we have ABC part, yeah? Okay, this is only a. Now, how do we do this? How can we do this? We have to express this in terms of a and b. So what do we do is, first of all, we can square root the 100x first. So over here, it will be log base 10. Now, square root of 100x will be 10x to the power of half. And then square root of the y squared will get y only. So isn't it this is log onto quotient? So next we can apply the law of indices. Yeah? Log of logarithm. Okay, so that will be log base 10 of 10x to the power of half minus log base 10 of y. Okay, I need some space over there. Then this one is the log onto the product. So when it is log onto the product, we will have log base 10 of 10 plus log base 10 of x to the power of half minus log base 10 of y is given here. Log base 10 of y is b, so we replace this with b. And at the same time, log base 10 of 10 is 1. So let's write the 1 here. And then the power can be brought down in front. So we will have half. So log base 10 of x. Log base 10 of x is given. That is a. So half a and then minus b. So we just found the answer for our part 6a. The next part, let's look at 6b. Now 6b say we need to solve the equation. All right, we have 2, this is b, 2 to the power of 2x times 5 to the power of 2x equals to 10 to the power of x minus 6. So how do we solve this one? Now, first of all, let's check, do they have the same base? Okay, or same index. So you look at this one, they have the same index. That means I can combine the base if they have the same index because of this. Okay, because of this, AB raised up to the power of m is the same as a to the power of m times b to the power of m, and vice versa. Since they have the same index, so we can factorize the index out, just write one time, and the base we just multiply them. Okay, so over here we will have 10 to the power x minus 6. So isn't it this one we will have 10 to the power of 2x equals to 10 to the power x minus 6. Same base. Single term. So immediately we know that the index should be equal. So 2x equals to x minus 6. Bring the x to the other side. We have 1x. So x equals to negative 6. So we just found the answer for part B. Now let's look at part C. So for part C, we need to solve the equation log base of 27 of x plus log base 3 of x equals to 4. Check, do they have the same base? They don't have. So first thing, we have to change it so that they have the same base. So we got to change the base here. So introduce base 3, log base 3. Always change the bigger number to the smaller number. So over here, we will have log base 3 onto the object over the log base 3 onto the original base, which is 27. 27 can be written in the base of 3, 3 to the power of 3. So plus log base 3 of x. Okay. Next, what can we do? This one, we can bring down the power to the front. So we will have log base 3 of x over 3. The log 3 is 1. So immediately I just write the 3 over here. Plus log base 3 of x equals to 4. Now, notice that both term is log base 3 of x. So we can actually combine these two. So multiply both sides with 3 to get rid of the fraction mode. So we will have log base 3 of x plus 3 log base 3 of x equals to 12. And then for this one, we can bring the coefficient up back to the power. So we will have log base 3 of x, or we can just do like this, log base 3 of x plus 3 log base 3 of x. So altogether we have 4 log base 3 of x equals to 12. Therefore, log base 3 of x equals to 3. So you want to find x, right? The log base 3, the function change to the other side. Log will become index in this format. So the base of the log will become the base of the index, and this 3 should go up then. So x is actually 27. Now what if just now I almost do the a bit slightly difficult part over here? What if I use that method, will I get the same answer? Let's check it out. So we have log base 3 of x plus log base 3 of x to the power of 3 equals to 12. Then in this case, I can group these two together, log base 3 onto the product. So we will have x to the power of 4 equals to 12. Then over here, we will have x to the power of 4 equals to 3 to the power of 12. Then to find x, we will, raise up to the power of 1 over 4. So 12 divided by 4 will be 3. So we get 27 also. We get back the same answer. But addition will be much simple and straightforward. Okay, this is question number 6. So we have done the section A. Let's go to section B now.